we begin now a chapter about confidence intervals. In statistics, we know that in general what we want to do is to construct on a basis of a sample of data. We want to construct estimates, let's say, of what happens in the general population. For example, in the Belgian population, we want to know, let's say, what is the mean height of the individuals. In this case, what we do, we are not going to measure all the people in Belgium. It's costly, it's really complicated, impossible in a way. And thus, in this case, what we are going to do is to take a sample, to draw a sample of individuals. We're going to measure them, and we're going to calculate the average of age, and we are going to say, okay, more or less, this average of age should estimate the mean of the height in the population, the mean of the height for an individual, for an individual, let's say in Belgium, for a given individual, for a general, I would say, individual in Belgium. Thus, okay, that is what we do in statistics. We have a population, it is too large. We say, okay, this population, it's too costly to make a full survey, to have the answer or to have a measure for every individual. And thus, in this case, what we do, okay, in this case, the only thing that we can do is to take a subsample, a subpopulation, a subset of the population. This subset of the population is a sample, and on this sample we make calculations, and we hope that these calculations estimate, we say, the quantity in the population. But that immediately involves an error. This procedure immediately involves an error, because it fully depends on the way we construct the sample. For every sample that we construct, we have a different average. If we pick up, let's say, 100 individuals, we compute the average of the measures of the age, let's say, for these 100 individuals. We have a value, but okay, if we construct another sample of size 100 individuals that we pick up at random, we compute the height for all of these individuals, and we compute the average of these heights. The average is different from the average that we calculated for the first sample. And it's the same if we construct the third sample and the fourth sample and so on. That means that according to the sample, we have different values for the average. But obviously, in Belgium, the mean of the height of all the individuals in Belgium, it's only one digit. And to estimate one digit, the mean, if we compute the mean of all the individuals in Belgium, if we have all the individuals at disposal, if we have the whole population at disposal, we can measure all the heights, and we can compute an average height. This average height, this is only one digit. And if we compute different samples, we have different digits for this average height computed on each sample. Thus the question is, immediately, what is the reliability? How reliable is an average computed on a sample? We would like to have some bounds. We would like to have things using an individual. We would like to have some bounds which say, okay, imagine that I can construct two bounds. the idea would be to construct two bounds such that inside these two bounds, I am almost sure, I will make it more precise, this almost later, but I am almost sure that between these two bounds, the true mean of the height in the population is between these two bounds. What I mean is that I would like to construct a confidence interval. And the confidence interval would say, okay, I would like to construct two bounds such that the mean of the height in the population is between these two bounds. I should be almost sure of that. But roughly, okay, the mean of the height should be between these two bounds. You understand? This measure, it is a complementary measure to the average that we could compute on a sample. Okay, the average that we compute on a sample, it depends on the sample. That means that according to the sample, we could have different values. We could have different values for the estimate, the estimate of the mean of the height, therefore of the average height. Therefore, according to each sample, we have different values for the average height. Okay, we have different values. Okay, but we would like to provide an interval. Provide an interval that I would say unclose all these possible values in a way. We would like to find an interval which limits in a way all these possible values that are given for every sample. We would like to provide this interval, or we would like to provide a quantity which is related to this interval. And therefore that means that intuitively what we are going to do, our objective in this chapter will be to say, okay, I'm going to construct an interval which is such that it contains the true mean of the height in the population. Not exactly, for which we are almost sure, for which we have a large probability, we will say, but we will construct an interval which has a very large probability to contain the true mean of the population, the true mean of the height in the population. That is our objective in this chapter. And obviously, we don't have a lot of samples in reality. In reality, we construct, in the real world, what we do, we construct one sample. We construct one sample with a size n, and therefore we are not going to be able to construct a lot of values of the average of the height. Would we be able to construct 1,000 samples, we would have 1,000 values of the average of the height. But in reality, what do we have? We only have one sample. We are not going to construct a lot of samples. We have one sample, and from this sample, it can be larger, but from this sample, we will compute an average of the height. Thus, we want to construct these two bounds that contain the true mean of the population with a large probability, but these two bounds should be constructed only on the basis of the sample. That we are going to see in the next part.